Welcome back once again. This is Web Security Essentials Part 1. Today we are going to learn about cross-origin resource sharing, also known as CORS. So what is CORS? It is a security feature that controls how resources are shared between different origins, and CORS is imposed by browser only. Okay. But why it matters? Let's see. Without CORS, anyone could access your server's data, leading to a potential security risk. So here, for example, we have CORS here, and here only the trusted client can send and receive data. Suppose we don't have CORS here. Okay, so any client can request from our server and they'll get back the data. Now let's make it simpler. Think of your API as a restaurant and your frontend as the delivery service. So only the trusted driver can pick up the data, which means the orders here. So suppose that here we have our trusted delivery partner and it can send and receive data, as you can see, because the origin here matches with the trusted origin of the restaurant. However, if there is some random delivery guy who try to pick data from the restaurant, which means the order from the restaurant, the CORS here blocks the request and it doesn't reach to the restaurant. But there is more. Before allowing access, the browser also do a pre-flight request. So what is a pre-flight request? The pre-flight request is something you can think of that the browser or the delivery service, in our case, sends a scout, which are option request, to check if the origin is allowed. So for example, the delivery service will send one of their scout to check to the restaurant, which means like, can I take the orders or what kind of orders I can take. So the CORS respond here with the value yes. This is just a pre-flight request. This is just for checking that what options are allowed from the API. Now the actual request then served by the server. So that's the pre-flight request. Without CORS header, the browser blocks the request even if the server responds. So for example, we don't have CORS set up on the server. Okay, so the browser will block every request from any domain unless it's from a trusted domain. So here we don't have any trusted domain because we don't have added any CORS header in our backend. So whatever request goes, we'll see this error: CORS policy violation, origin not allowed. So key concept of CORS. There are like 4 key concept of CORS. There is a trusted origin, like from what origin the request can be served. Then we can like specify what methods we are allowing for the clients to access, like get, post, put, delete or whatever. So this is controlled by the access control allow method. Similarly, there is a label for header also, like access control allow headers, and there we can specify multiple header options. So here for example, we are allowing content type and authorization. There is also one for credential, for including cookies or other stuff. This is enabled by access control allow credentials with true option. Now let's look at some good versus bad practices. So the good practice here will be like, we on the server specify what origins we are allowing. Okay, so some of our trusted origins, and when the request comes, like it checks for the trusted origin and it like responds back. Bad practice can be like using the wildcard for trusted origin. So this can be like many of the requests will be coming from random sources and the server has to respond in any case because we are using here our wildcard entry. So CORS is like a bouncer for your API. Set the rules right and your data stays secure. So here for example, here the delivery drivers come, the guards checks, the guard here is the CORS here, and it goes to the restaurants and the restaurant respond back with the data here. Okay, now let's see some setup for CORS in advanced scenario. Serverless platform like AWS Lambda Azure functions handle CORS in the API gateway layer. So the gateway acts as a security checkpoint, then validates origin before forwarding the request. Developer configure CORS in the API gateway setting, not in the serverless function. So you don't have to add CORS here separately. We just use an API gateway and impose CORS here. So the trusted request will go to the serverless function. However, the malicious request will be blocked. In microservices, each service might expose their own API. So consistent policy is needed for internal communication between services plus external request. So using API gateway or a centralized configuration is usually a good choice. So here we can also use API gateway to like configure how the internal microservices communicate and how the external requests are being handled by the client and the API gateway. But now let's look at a code example here. So here we have index.html here. Here we are hitting localhost 8000 and we are like consoling the data. Here we have a button. Okay, now this is our server file, and here like we are adding all the headers we have discussed in the video, like access control, allow origin, allow methods, allow headers, and allow credentials. And this is our allowed origin. So unless we are like sending requests from localhost 3000, all the requests should be blocked. And this is like normal node server here. So let's run our server. The server is running on localhost 8000. Here we'll serve our backend. So let's run on 3001 here, for example. Here we are on the localhost 3001. So when we'll click fetch data, you can see the status here is CORS error. Okay, you can see it in the console as well that there is error. Now let's close this and run the server on localhost 3000. So as you know that we have added 3000 as our trusted origin on our server. So now when we click fetch data, you can see that we get the message CORS is working, and on the network tab also the status is 200. Okay, so these are all the things we have learned here. I'll put a link in the description for a detailed reading on this topic. So thanks for watching. Please like, comment and share, and please not forget to subscribe.